Assistant Professor in Andhra Pradesh State University's Electronics and Communication Engineering 2018 Question Paper Solutions Part 2, that is from question number 31 to question number 60. Question number 31. Given series RLC circuit with the value of resistance 3 ohm, inductance 3 millihenry, capacitance of 100 microfarad, the response of current in the circuit is. So we know that the characteristic equation of series RLC circuit is S square plus R by L into S plus 1 by LC is equal to 0 if R by 2L greater than 1 by LC, then the roots are real and unequal. System is having overdamped response. If R by 2L is equal to 1 by root LC, the roots are real and equal. The response is critically damped. If R by 2L less than 1 by root LC, roots are complex conjugate to each other and the response of the system is underdamped response. So based on these conditions, first we need to calculate the value of R by 2L and 1 by root LC. So given R is 3 ohms and inductance is 3 millihenry. So it is 500, its value is 500. 1 by root LC, 1 by square root of inductance is 3 millihenry, 3 into 10 power minus 3, 100 micro, 10 power minus 6. So that is, its value is 1825.74. Here R by 2L less than 1 by root LC. Therefore, the response is underdamped. The response of current in series RLC circuit is underdamped response. So correct option is 3. Question number 32. The quality factor of parallel resonant circuit. So parallel resonant circuit. So we know that the quality factor of series resonant circuit is series RLC circuit is omega naught L by R, that is 1 by omega naught RC equal to 1 by R square root of L by C. Similarly, the quality factor for parallel resonant circuit, parallel RLC circuit is R by omega naught L, 1 by omega naught RC, R into square root of C by L. Therefore, correct option is R into square root of C by L. The quality factor for series parallel resonant circuit is R into square root of C by L. Correct option is 4. Next question. The bandwidth of series resonant circuit with resistance 1 kilo ohm, inductance 1 millihenry, capacitance 1 femtofarad is. We know that the formula for quality factor, bandwidth and frequency relationship is quality factor is equal to resonant frequency by bandwidth. Resonant frequency is 1 by 2 pi square root LC into hertz, or omega naught is equal to 1 by square root of LC radian per second. To calculate the bandwidth directly, the formula is bandwidth is equal to resistance by inductance. Given resistance is 1 kilo ohm, 1 into 10 power minus 3, 1 into 10 power 3 and 1 millihenry, 1 into 10 power minus 3. So that is 10 power 6 hertz. So the bandwidth of given series RLC circuit is 1 megahertz. So correct option is 1. So this is the direct formula, that is bandwidth is equal to R by L hertz. Next question. The value of current through the inductor at t is equal to 0 plus is. So we know that given circuit, here switch is opened at t is equal to 0. So switch is open at t is equal to 0. At t is equal to 0 minus switch is closed at t is equal to 0 plus switch is open. Also, the circuit consists of inductor and capacitor. So this capacitor blocks DC, allows AC. Inductor allows DC, blocks AC. Supply voltage is DC voltage. So 1 volt DC source is given at t is equal to 0 plus switch is open. At t is equal to 0 plus switch is open. The current in the circuit is 0. Therefore, I of 0 plus is 0. The current is 0 amperes. At t is equal to 0 minus, switch is closed for a long time duration, that is from minus infinity seconds to t is equal to 0 minus second. At steady state, capacitor gets open circuited and inductor gets short circuit to DC. So capacitor is open circuited and inductor gets short circuited. So capacitor gets open circuited and inductor gets short circuited. Therefore, once capacitor is open circuited, current at 0 minus is, the current through the inductor is 0 amperes. The current through the inductor does not change instantaneously. The current at IL of 0 minus is 0 amperes. Therefore, current at IL of 0 plus is also 0 ampere. So correct option is 3. The value of current through the inductor at IL of 0 plus is 0 amperes. The value of H22 for the circuit shown in the figure. H22, it is a hybrid parameter. So hybrid parameters for two-port networks are given as V1 is equal to H11 I1, H12 V2, I2 is equal to H21 I1 plus H22 V2. So to calculate this H22, open circuit the input port, that is current at the input port is 0, H22 is equal to I2 by V2 for input port open circuited. Output admittance with input port open circuited. As input port is open circuited, the current I1 is 0. The current I1 is 0. Therefore, if I1 is 0, I1 R1 is also 0 volts. So voltage at node A, let us assume this point as node A. Voltage at node A is equal to output voltage V2, output voltage V2, which is same as input voltage V1. Therefore, V2 voltage is current I2, into R2, because I1 is 0. So current I2 into R2. R2 value is 20 ohms. V2 by I2 is 20 ohms. Now we need to calculate I2 by V2. So I2 by V2 is 1 by 20 mho. So 1 by 20 value is 0.05 mhos. That is H22. H22 is I2 by V2 for input port. I1 is open circuited. Correct answer is 0.05 mhos. Option 4. Question number 36. The condition for symmetry of the network is. A two-port network is said to be symmetrical if the network looks same from both the ports, otherwise it is said to be asymmetrical. A two-port network is said to be symmetrical if the network looks same from both the ports, otherwise it is said to be asymmetrical. Or one more definition for symmetry is, a symmetrical two-port network is a network which is divided into two equal halves with each half as a mirror image of each other. So we can divide this symmetrical network into two equal halves. The first half is mirror image to the second half. This is one more definition for symmetrical network. So the conditions for symmetry For Z parameters or open circuit parameters or impedance parameters is Z11 is equal to Z22. Similarly, for Y parameters, short circuit parameters, admittance parameters is Y11 is equal to Y22. The condition for symmetry of ABCD parameters or transmission parameters is A is equal to D. For inverse transmission parameters, A dash is equal to D dash. For hybrid parameters, the condition for symmetry is delta H is equal to 1. Similarly, for inverse hybrid parameters, the condition for symmetry is delta G is equal to 1. Now, the condition for symmetry of a network is Z11 is equal to Z22. It is wrong. AD minus BC is equal to 1. It is also wrong because the condition for symmetry is A is equal to D in case of transmission parameters. In case of hybrid parameters, delta H is equal to 1. That is H11 H22 minus H12 H21 is equal to 1. Correct option is 3. Question number 37. The maximum value of mutual inductance of two inductively coupled coils having equal self-inductance is 6 millihenry is. So we know that the formula for mutual inductance M is equal to K root L1 L2. M is equal to K root L1 L2, where L1 L2 are self-inductance of the coils, K is the coefficient of coupling, and this mutual inductance is maximum when the coils are perfectly coupled. That is, for perfect coupling, the value of K is, for perfectly coupled coils, the value of K is 1, implies mutual inductance is maximum. Now calculate the value of mutual inductance. M is equal to K into root L1 L2. The coils are having self inductance of 6 millihenry. So K is 1. For maximum mutual inductance, 6 millihenry into 6 millihenry. Therefore, the answer is 6 millihenry. So maximum mutual inductance is 6 millihenry. Correct option 1. Question number 38. It is related to the properties of continuous time impulse function. So let us see the properties for continuous time impulse function. The first property is scaling property. Scaling property. So scaling delta of AT is equal to 1 by mod A delta of T. Similarly, delta of AT plus or minus B is 1 by mod A delta of T plus or minus B by A. This is a scaling property of impulse function. So let us keep A is equal to minus 1 here. Then delta of minus T is equal to 1 by mod of minus 1 delta of T, that is delta of T. Hence this impulse function is a even function of time. Impulse function is even function. Statement A is correct. Next property of impulse is product property or multiplication property. So x of t delta of t minus t naught is equal to x of t naught delta of t minus t naught. If t is equal to 0, then x of t delta of t is equal to x of 0 delta of t. Next, third property is convolution property. X of t delta of t minus t naught is equal to x of t minus t naught, x of t minus t naught. If t naught is 0, x of t delta of t is equal to x of t. The convolution of a signal with impulse produces the original signal itself. And then derivative property delta of t is equal to d by dt of u of t, unit step signal. And sampling property is integral minus infinity to infinity x of t delta of t minus t naught into dt is equal to x of t naught. If t naught is 0, then integral minus infinity to infinity x of t delta of t dt is x of 0. So these are the 5 different properties of this is first derivative of unit step function gives impulse, and this is a sampling property. Sampling property, derivative property, convolution, multiplication property and scaling property. So from these properties the question has been asked related to unit impulse signal. So this unit impulse is even function. Statement A is correct. It is a derivative of unit ramp function. Statement B is wrong because impulse is a derivative of unit it's a derivative of unit step function. Next, delta of t minus t naught into f of t convolution of f of t delta of t minus t naught is f of t minus t naught. So see the convolution property, x of t delta of t minus t naught is x of t minus t naught. Here it is f of t minus t naught. Statement C is correct. Therefore correct option is only A and C are correct. Question number 39. Which of the following statement is true related to causal system? A system is said to be causal if the response depends on present input and past inputs but not on future inputs. Causal systems are non-anticipative systems and are physically realizable. These causal systems need not be stable. So causal systems are always stable. Statement A is wrong. Statement 2, the output depends only on past inputs. It depends on past inputs as well as present inputs. Statement 2, wrong. The output of the system depends on present and future inputs. Output doesn't depend on future inputs. These systems are otherwise called non-anticipating systems. Statement 4 is correct. Next question. The jet transform of a signal is defined as x of n is equal to u of n minus u of n minus 1. So let us see the z transform for u of n, that is 1 by 1 minus z inverse, and the region of convergence is mod z greater than 1. For u of n minus n naught, shifted the signal by n naught does not change its ROC, but the z transform is z power minus n naught divided by 1 minus z inverse, where region of convergence is same, mod z greater than 1. Now given signal is u of n minus u of n minus 11. This is a given signal. By applying linearity property, z transform of u of n minus z transform of u of n minus 11. So we know that z transform of u of n is 1 by 1 minus z inverse, 1 by 1 minus z inverse, minus z transform of u of n minus n naught is z transform of z of minus n naught minus 11 by 1 minus z inverse. That is, denominator is common, 1 minus z power minus 11 divided by 1 minus z inverse, and the region of convergence is mod z greater than 1. Correct option is 3. 1 minus z power minus 11 by 1 minus z inverse. Question number 41. It is related to initial value theorem of Laplace transform. Initial value theorem in Laplace transform. So that is limit t tends to 0, I of t is equal to I of 0, that is which is equal to limit s tends to infinity s into I of s. Given function I of s is 12 into s plus 18 by s into s plus 9. And the initial value of I of t is I of 0, that is limit s tends to infinity s into I of s. Limit s tends to infinity s into given I of s is 12 into s plus 8 by s into s plus 9. S get cancelled. 12 into 1 plus 8 by s divided by 1 plus 9 by s. So replace s with infinity. We will get 12 into 1 plus 0 by 1 plus 0. So it is 12. The correct option is 3. The initial value of given function I of t is 12. Question number 42. A message signal m of t given as m of t is equal to 14 cos 50t 14 cos 50t plus 18 cos 250t plus 10 cos 300t. So compare this message signal with m of t is equal to a1 cos 2 pi f1t a2 sin 2 pi f22 into t a3 cos 2 pi frequency f3 into t. Here on comparison the amplitude a1 is 14, amplitude amplitude a2 is 18, amplitude a3 is 10, and the frequency 2 pi f1 is 50, therefore f1 is 50 by 2 pi hertz, and the frequency f2 is 250 by 2 pi hertz, frequency f3 is 300 by 2 pi hertz. These are the three different frequencies. Now we need to calculate the sampling rate for the given signal. Nyquist rate, Nyquist sampling rate. So maximum frequency component in the given signal. So that is the highest frequency component here is the highest among 50 by 2 pi, 250 by 2 pi and 300 by 2 pi is maximum of f1 plus f2 plus f3, which is 300 by 2 pi. This is the highest frequency component of given message signal. Now Nyquist rate is 2 times of maximum sampling frequency or highest frequency in the given message signal, that is 2 into 300 by 2 pi. 300 by pi. This is the Nyquist rate. 300 by pi is the Nyquist rate, which is a there is no option correct option. Hence, this question is deleted. Question number 42 is deleted because none of the options are correct. The Nyquist rate is equal to twice the highest frequency component in the message signal. Nyquist rate is 2 times of highest frequency component of message signal. So as per calculations, there is no correct answer. Hence, the question is deleted from the question paper. Question number 43. Given Z transform, x of z is equal to z into 15z minus 17 divided by 8z square minus 17z plus 9. Then final value is, we know that the final value theorem in Z transform is given as x of infinity is equal to limit z tends to 1 minus z inverse x of z, and this final value theorem is applicable if pole of 1 minus z inverse x of z must lie within the unit circle. Given function x of z is equal to z into 15z minus 17 divided by 8z square minus 17z plus 9. Rearrange the given expression. After rearranging, it is 17z inverse minus 15 by 9 into 1 minus z inverse minus 0.88. Now apply this final value theorem x of infinity to calculate the final value. X of infinity is equal to limit z tends to 1 minus z inverse x of z. Replace this x of z as, entire this value that is 1 minus z inverse 17 z inverse minus 15 divided by 9 into 1 minus z inverse minus 0.88. This 1 minus z inverse get cancelled and keep the value z is equal to 1. 17 minus 15 divided by 9 into 1 minus 0.88, that is 2 by 9, 1 minus 0.88. On calculation, its value is 1.98, which is approximately equal to 2. The final value for the given z transform is 2. Correct option is 4. Next question. The direct form to structure for the given figure is. Here the input is x of n and the output given is y of n. So the structure has two delay elements, each z inverse, and a feed forward path. Input coefficients of x of n are multiplied by 3, and feedback or recursive coefficients. First delay path is minus 0.1 and second delay path is plus 0.2, minus 0.1 plus 0.2. And direct form and delay path from output has weights of 1.2, 1.2 and 0.2. This is the given question. And this direct form to realization requires m plus n plus 1 multiplications, m plus n additions, and maximum of mn memory locations, where m and n are the order of numerator and denominator transfer function that to be realized. So these are the coefficients related to output, and these are the coefficients related to the input. Now the output y of n is minus 0.1 y of n minus 1 plus 0.2 y of n minus 2, 3 into x of n, 3 into 1.2, that is 3.6 into x of n minus 1, 3.6 into 3 into 1.2, 3.6 into x of n minus 1, 0.2 into 3, that is 0.6 into x of n minus 2, and these are the coefficients related to output term, minus 0.1 y of n minus 1, y of n minus 2, 0.2 into y of n minus 2. Coefficients related to output y term, and these are the coefficients related to the input x term. The output expression y of n is equal to minus 0.1 y of n minus 1 plus 0.2 y of n minus 2, 3 into x of n plus 3 into 1.2, that is 3.6 into x of n minus 1 plus 0.6 into x of n minus 2. So here none of the options are correct. The correct answer is, this expression is the correct answer. Next question, question number 45. So in this question we need to find the Fourier series coefficients of continuous time periodic signal. So this periodic signal x of t given is, x of t is equal to 1 for mod t less than t1 and it is 0 in all other time period. Here in x of t, the non-zero portion of signal is symmetric around 0 with amplitude 1 in the time interval minus t1 to plus t1. So therefore the given signal x of t is even periodic signal. Therefore, the Fourier series coefficients consist of only ak terms, only a coefficients. Ak is equal to 1 by t naught minus t naught by 2 plus t naught by 2 x of t e power minus jk omega naught t into dt. So keep the values here. Now x of t is equal to 1 by t naught minus t12 plus t1. Here t1 is capital T1. E power x of t value is 1. The magnitude is 1. E power minus j k omega naught small t into dt. On integration 1 by t naught e power minus j omega minus jk minus jk omega naught t divided by minus jk omega naught and the limits of integration is from minus t1 to t2. Integral e power ax dx is e power ax divided by a plus some constant, and there is one more formula e power j omega minus e power minus j omega by 2j is sin omega t. Apply the second formula here. On integration, its value is 1 by t naught ak is equal to 1 by t naught e power minus jk omega naught t2 minus e power minus jk omega naught t1 divided by minus jk omega naught. So multiply by 2 and divided by 2. It can be written as 1 by t naught sin k omega naught t1 by k omega naught. So we know that ak is 1 by t naught 2 sin, so here it is multiply with 2, 1 by t naught 2 sin k omega naught t1 divided by k into omega naught. Omega naught is 2 pi by t naught. Now t naught get cancelled. So this t naught 2 will get cancelled. The resultant answer is sin k omega naught t1 divided by pi k. This is the Fourier coefficient for the given signal x of t. Ak is 1 by pi k sin k omega naught t1, 1 by pi k sin k omega naught t1. Therefore, correct answer is option 1. Next question. Fourier transform of signal x of t is equal to 2 by t square plus 1 is. We know that the duality theorem is if Fourier transform of small x of t is capital X of omega, then Fourier transform of capital X of t is equal to 2 pi small x of minus omega. Fourier transform of and the Fourier transform of f of e power minus at f of e power minus a mod t is equal to 2a by a square plus omega square. Put a is equal to 1, then Fourier transform of e power minus mod t is equal to 2 into 1 by omega square plus 1, that is 2 by 1 plus omega square. Here small x of t is e power minus mod t and x of omega is 2 by 1 plus omega square. So keep omega as t. Capital X of t is equal to 2 by 1 plus t square. So this is a question given. The signal is 2 by 1 plus t square. Apply duality theorem. The Fourier transform of 2 by 1 plus t square is equal to 2 pi small x of minus omega. So small x of t is e power minus mod t 2 pi e power minus mod omega, that is omega only. So correct answer is 2 pi e power minus mod omega. Fourier transform of 2 by 1 plus t square is equal to 2 pi e power minus mod omega. So we need to solve this problem by using duality theorem. So the duality theorem of Fourier transform says that if Fourier transform of x of t is equal to x of omega, then Fourier transform of capital X of t is equal to 2 pi small x of minus omega. So take Fourier transform of e power minus mod t. So e power minus mod t, this is the first step to calculate. So here x of t is equal to e power minus mod t, capital X of omega is equal to 2 by 1 plus omega square, capital X of t is equal to 2 by 1 plus t square, which is a given question. This is a given question we need to solve. So Fourier transform of 2 by 1 plus t square is equal to Fourier transform of 2 pi, that is 2 pi small x of minus omega. Correct answer is 3. Next question. The inverse z transform of x of z is equal to log of 1 plus 2 z inverse mod z greater than 2. So we know that if x of z is equal to log of 1 plus a z inverse for mod z greater than a, then x of n is minus 1 power n plus 1 a power n u of n minus 1 by n for n greater than or equal to 1, and it is 0 for n less than 0. In the question, x of z is equal to log of 1 plus 2 z inverse mod z greater than 2. Here the value of n, a is equal to 2, then x of n is minus 1 power n plus n 2 power n u of n minus 1 by n minus 1 power n minus 1 power 1 2 power n u of n minus 1 by n minus 1 power n can be written as this minus 1 into 2 minus 2 and minus 1 power 1 is 1 minus 1 power n into 2 power n, it can be written as minus 2 whole power n. Minus 2 whole power n minus u of n minus 1 by n. So correct answer is minus of minus 2 whole power n u of n minus 1 by n. Next question. The energy band gap of silicon at 0 Kelvin. So we know that energy band gap is the minimum energy difference between top of the valency band and bottom of the conduction band. This energy band gap is a function of temperature and interatomic spacing. If temperature increases, energy band gap Eg decreases. If interatomic spacing or atomic concentration increases, interatomic spacing obviously decreases. If interatomic spacing decreases, energy band gap increases. So energy band gap is a function of temperature. As temperature increases, energy band gap decreases, and energy band gap is a function of interatomic spacing. As atomic concentration increases, spacing decreases, therefore energy band gap increases. The energy band gap for silicon is given as Eg of T is equal to 1.21 minus 3.6 into 10 power minus 4 into T, and for germanium it is Eg of T is equal to 0.785 minus 2.23 into 10 power minus 4 into T. This is the formula for energy band gap to calculate the energy band gap for silicon and germanium. Now at T is equal to 300 Kelvin, for silicon its value is 1 point, energy band gap is 1.11 electron volts. For germanium it is 0.72 electron volts. At T is equal to 0 Kelvin, silicon energy band gap is 1.21 electron volts, and for germanium it is 0.785 electron volts. In the question, the energy band gap of silicon at 0 Kelvin. For silicon at 0 Kelvin is 1.21. So 1.21. Option 3 is the correct answer. Next, question number 49. It is related to diffusion length. So diffusion length is given as the average distance that a carrier travels or diffuses before recombination. Diffusion length is equal to square root of d into tau, where d is diffusion length, tau is a minority carrier lifetime. So diffusion length for holes can be written as Lp is equal to under root of dp into tau p. Correct option is 1. Question number 50. The ripple factor of half wave rectifier is. We know that ripple factor is a measure of fluctuating component in the AC component in the output of rectifier. This ripple factor is given as RMS value of AC component to average value of the wave. The ripple factor for half wave rectifier is 1.21 and ripple factor for full wave rectifier is 0.48. Whether it is an bridge type full wave rectifier or center tapped full wave rectifier. Ripple factor is 0.48. In the question they have asked ripple factor of half wave rectifier. For half wave rectifier answer is 1.21. So there is no 1.21 in the given options. This question is deleted from the question paper. Next question, the transportation factor beta star of PNP transistor is. We know that the base transportation factor beta star is equal to, it is a ratio of injected carrier current reaching at collector junction to injected carrier current at the emitter junction. So that is beta star is equal to injected carrier current reaching at collector junction JC to injected carrier current reaching at emitter junction JE. Beta star is equal to IPC by IPE for PNP transistor, INC by INE for NPN transistor. Because in PNP transistor majority carriers are holes, which is represented as P. Therefore transportation factor beta star in PNP transistor is IPC by IPE. Next question. Question number 52. The condition to be satisfied to prevent thermal runaway. So that is the rate at which heat is released. Dou Pc by dou Tg. Tj suffix j, temperature at the junction. The rate at which heat is released is less than the rate at which heat is dissipated. That means rate of dissipation should be more than the rate of heat released. So correct option is 4. To prevent thermal runaway, the rate at which heat released at the junction must not exceed the rate at which heat is dissipated. Dou Pc by dou Tj, temperature at the junction, less than or equal to dou Pd by dou Pj. Correct option is 4. Next question. Question number 54. The reverse bias voltage exists across the source substrate of PN junction, and change in the source substrate junction voltage changes the threshold voltage, and this effect is called. So the change in transistor threshold voltage because of voltage difference between source and drain is called body effect. So correct answer is 2. Due to body effect, threshold voltage decreases, and hence the drain current also decreases. To avoid this body effect, the body should be connected to ground or source terminal in case of N channel MOSFET, or it is connected to VDD or source terminal in case of P channel MOSFET. Let us see some more points related to base width modulation. This base width modulation is also called early effect, or early effect is also called base width modulation. As collected to base junction reverse bias voltage, increases the width of collector junction depletion region increases. Due to this, electrical or physical base width decreases. As collector junction reverse bias voltage varies, the width of the base is also varying. Therefore, it is called base width modulation or early effect. And there is one more term, that is barrier effect. So this barrier effect generally refers to the potential barrier formed at the PN junction that prevents carrier movement until barrier external potential is applied, which is greater than the barrier potential. This barrier influences the flow of charge carriers across the junction. But as per the question, the answer is body effect. Next question. So JFET is given. For the JFET, drain current in saturation is given as ID is equal to IDSS 1 minus VGS by VP whole square. So that is ID is drain current in the saturation region. Given IDSS is 2 milliamperes at VGS is equal to 0, ID is equal to IDSS, which is 2 milliamperes. At VGS is equal to half of pinch off voltage Vp by 2, ID is equal to IDSS 1 minus Vp by 2 divided by Vp whole square, that is IDSS by 4. For VGS is equal to 0, ID is equal to IDSS. For VGS is equal to Vp by 2, IDSS is drain current is 0.25 times of IDSS. 0.25 times of IDSS. Next, at VGS is equal to 0, we know that VGS, drain source voltage, and gate source voltage as related as VDS is equal to VGS minus pinch of voltage VP. Again, at VGS is equal to 0, this drain source voltage is minus pinch of voltage, that is minus 3.5 volts. Given pinch of voltage is minus 3.5 volts. Therefore, drain source voltage is 3.5 volts. At VGS is equal to VP by 2, VGS is equal to VP by 2. Drain source voltage VDS is equal to VP by 2 minus VP, that is minus VP by 2. So minus of minus 3.5 volts by 2, its value is 1.75 volts. Correct? Next question. When voltmeter is placed across a forward biased diode, what is the value of voltmeter reading? If the diode is ideal diode, then for ideal diode, breakdown voltage is 0. The reading in the voltmeter is 0 volts. If the diode is a practical diode, this practical diode has a junction voltage of V gamma, then the reading in the voltmeter is approximately equal to diode barrier potential. The correct answer is the diode barrier potential. So in this question, if diode ideal, then voltmeter reading is 0. So option 1 is also treated as correct, because in the question they did not mention whether it is an ideal diode or practical diode. If the diode is practical, diode, then voltmeter reading is same as or approximately equal to diode junction voltage or diode barrier potential. Option 1 is correct if diode is treated as ideal diode. Option 4 is correct if diode is taken as a practical diode. Question number 57. In G0 diode, the load regulation is determined by. So we know that load regulation is variation of output voltage as a function of load current. And the percentage load regulation is given as V no load voltage minus full load voltage by full load voltage into 100 percentage. In G0 diode, this load regulation is determined by change in load current IL and output voltage V0. So this load regulation is determined by change in load current and output voltage. So correct option is 1. Question number 58. Gallium arsenide phosphide LED emits red color light, green color light and yellow color light depending upon the doping. Therefore correct answer is option 1 and option 3. Red, yellow, red, green or red, green visible light. Question number 59. It is related to photodiode. So photodiode is also known as light operated switch. It works on the principle of photoconductive effect. This photoconductive effect is also called photoresistive effect. That is, when light falls on a semiconductor, its conductivity gets increases, and these photodiodes are always operated in reverse bias condition. Its internal resistance decreases with increase in light intensity. So internal resistance of photodiode decreases with increase in light intensity. The conductivity of photodiode resistance decreases as light intensity increases. Conductivity increases when the photodiode is exposed to light. Correct answer is 2. Next question. The no load condition means. So no load condition means either load has infinite resistance. No load condition means open circuited. Output terminals are open circuited. Therefore correct answers are the load has infinite resistance, output terminals are open circuited, or the load has infinite resistance and output terminals are open circuited. Option 1, 3 and 4 are correct.